Look up at the night sky, and you might think you are looking at space, but you are not. You are looking at time. Every photon of light hitting your eyes is a tiny cosmic postcard sent from the past. For decades, I believed, as did nearly every physicist on this planet, that we understood the limits of that past. We believed the universe had a definitive birth, a grand beginning 13.8 billion years ago. And that light could not possibly be older than the moment time itself began. Then we built a machine. We launched the James Webb Space Telescope 1 million miles into the freezing empty dark, aiming its golden mirror at the deepest blackness of space. We expected to see the faint, very delicate baby pictures of the very first stars slowly coming together. Instead, what I saw and what sent a shiver through the entire scientific community was something impossible. Deep in the cosmic dawn, at a time when the universe was supposed to be a dark, chaotic soup of hydrogen, James Webb caught sight of fully formed, massive, brilliant galaxies. Stars that should have taken billions of years to ignite were already burning bright, casting light across the cosmos at a moment when time itself was barely taking its first breath. According to our standard models of physics, this light should not exist. It is as if you walked into an empty nursery and found a fully grown adult sitting in a cradle. If you are fascinated by these profound puzzles of reality, take a moment to subscribe and join us as we explore the outer boundaries of human knowledge, because what James Webb has revealed is not just a glitch in our instruments. It is a crack in the foundation of modern physics. And today I want to walk you through what this light truly means for our understanding of reality. Let us start by grounding ourselves in a fundamental truth of our reality. One that is easy to forget in our fast-paced world. Everything you see, absolutely everything, is an illusion of the present. When you sit on your porch on a warm summer evening and watch a distant thunderstorm, you know that the flash of lightning and the rumble of thunder occurred at the exact same moment, but you see the flash long before you hear the thunder because sound travels slowly. You accept without hesitation that the thunderclap you are hearing right now actually happened in the past. Light behaves in the exact same way, just on a much grander scale. Light travels at an absolute speed limit of exactly 299,792 kilometers per second. That is incredibly fast, so fast that here on Earth it feels instantaneous. But space is incomprehensibly vast. By the time the light from our sun reaches your face, 8 minutes have already passed. If the sun were to suddenly blink out of existence right now, we would not know about it for 8 full minutes. We would continue to go about our day bathed in the phantom light of a ghost star. This means that every telescope we build is in a very literal sense a time machine. When I look through a telescope at the Andromeda Galaxy, our nearest large galactic neighbor, I am not seeing it as it is today. I am seeing it as it was 2.5 million years ago. I am capturing light that began its journey long before modern humans even walked the Earth. For the last H100 red years, physicists like myself have used this cosmic time machine to piece together the ultimate history book of reality. We mapped the stars, we measured the expansion of the universe, and we ran the cosmic clock backward to a profound and inescapable conclusion. 13.8 billion years ago, everything we know, all space and all time, began in a singular, intensely hot and dense state, the Big Bang. But the universe did not instantly look the way it does now. According to our most rigorously tested theories, after that initial flash of creation, the cosmos expanded and cooled. It became a thick, opaque fog of neutral hydrogen gas. There were no stars, there were no planets, there was no light. We call this vast, silent stretch of time the cosmic dark ages. Think of it like a grand old theater just before the performance begins. The stage is vast, the heavy curtain is drawn, and the props are slowly being moved into place in absolute pitch blackness in the universe. Those props were giant clouds of gas, and the stagehand was gravity very silently and patiently pulling this hydrogen together. But gravity is a weak force, and it takes an immense amount of time to do its work. In our standard model of cosmology, it takes hundreds of millions of years for these gas clouds to become dense enough and hot enough to ignite the fires of nuclear fusion. We expected the first stars to turn on slowly, one by one, like old streetlights flickering to life in a sprawling, dark city. We expected the very first galaxies to be small, fragile, and chaotic. They were supposed to be messy, very primitive little clumps of matter that would eventually, over billions of years of slow cosmic evolution, merge to form grand, majestic spiral galaxies like our own Milky Way. This was the solid foundation of modern astrophysics. It made perfect mathematical sense. It followed the strict laws of thermodynamics and gravity that we observe every single day. And this is exactly why we built the James Webb Space Telescope. As space itself expands, it physically stretches the light traveling through it. Light that started out as brilliant ultraviolet rays from those very first stars gets stretched into longer invisible wavelengths. By the time it reaches Earth, it becomes infrared light. James Webb was perfectly designed to capture this ancient stretched out light. We built it to look past the cosmic dark ages and finally witness the slow, delicate birth of the first baby galaxies. We thought we knew exactly what we were going to find, but the moment James Webb focused its golden mirrors into that ancient dark, the data that came back did not match our beautiful theories. What we saw shattered the foundation we had spent a century building. When I first looked at the data coming down from James Webb, I felt a profound sense of disorientation. We were staring at patches of deep space so tiny that from Earth they appear about the size of a grain of sand held at arm's length against the night sky. But in that tiny speck of nothingness, James Webb captured infrared light that had been traveling toward us for over 13.5 billion years. We were looking at the universe when it was barely a toddler, just a few 100 million years after the Big Bang. According to everything we knew, everything I have taught in university lecture halls for decades, we should have seen the faint, disorganized flickers of the very first stars slowly pulling themselves out of the primordial fog. But we did not see delicate baby galaxies. We saw monsters. We found galaxies that were massive, very highly structured, and teeming with billions of mature stars. To understand why this is so deeply unsettling, I want you to imagine walking into a forest that you know for an absolute fact was planted exactly 1 year ago. You expect to see saplings, small, fragile green shoots just barely poking through the soil, but instead you walk in and find towering redwood trees hundreds of feet tall with thick bark and massive root systems. Your mind instantly tells you that this is impossible. A tree cannot grow that large in a single year. The laws of biology simply do not allow it. This is exactly what we are facing in astrophysics right now. The strict rules of gravity and thermodynamics that we have tested and verified over a century simply do not allow a galaxy as massive as our Milky Way to form in just 300 or 400 million years. Building clear's throat, a giant galaxy, requires a long, violent, and very slow history. First, invisible dark matter has to slowly clump together over eons, creating a massive gravitational scaffold. Then ordinary gas has to fall into these unseen dark matter wells. The gas has to heat up from friction, then radiate that heat away, cool down, fragment, and finally compress into stars. Then those early star clusters must repeatedly collide and merge. It is a chaotic, destructive process that takes billions of years to settle down into a recognizable shape. Yet the light James Webb captured shows galaxies that already have the mass of 10 to 100 billion suns. Even more shocking, some of them possess smooth, perfectly settled disks. That kind of structural maturity comes only from billions of years of quiet, uninterrupted rotation. Some of these ancient galaxies even contain supermassive black holes at their centers, objects so impossibly dense and gravitationally dominant that we cannot even begin to explain how they could have consumed enough matter to grow so large in such a short fraction of cosmic time. And then the mystery deepens even further when we use our instruments to break this ancient light apart and read its hidden chemical fingerprint. We see something that makes the hair on the back of my neck stand up. We see the heavy, unmistakable signature of cosmic dust. We see elements like carbon and oxygen. Why is that a problem? Because in the very beginning, the universe was made entirely of pristine hydrogen and helium. There was absolutely no carbon, no oxygen, no iron. Those heavier elements are forged only inside the crushing nuclear furnaces of massive stars, and they are only released into the cosmos when those stars reach the end of their lives and explode in spectacular supernovas. To see a galaxy filled with cosmic dust and heavy metals means that multiple generations of stars have already been born, lived out their entire life cycles of millions of years, and died in fiery explosions. All of this happened within a time frame where mathematically even the very first generation of stars should barely be turning on. The timeline is broken. We are staring at ancient light that carries the undeniable signature of billions of years of cosmic history. Yet it exists in a universe that is only a few 100 million years old. How can a structure be older than the environment it exists within? We are forced to confront an uncomfortable truth. The universe is whispering to us that our understanding of time and creation is fundamentally flawed. To understand the sheer magnitude of this paradox, I need to show you exactly how we know the age of this light. We do not just guess. We measure it using one of the most reliable and rigorously tested tools in all of physics. It is a phenomenon you actually experience on a regular basis, just in a different form. Think about standing on a sidewalk as an ambulance speeds past you with its siren blaring. As the ambulance races toward you, the sound waves are compressed and you hear a high, piercing pitch. But the exact moment it passes you and speeds away, the pitch drops noticeably. The sound waves are being stretched out by the motion of the vehicle. This is called the Doppler effect. Light behaves in the exact same way. If an object is moving away from us, the light waves it emits get stretched out. In the spectrum of visible light, the longest wavelengths are red. So when a galaxy is moving away from us, its light is stretched and shifted toward the red end of the spectrum. We call this cosmological red shift. But here is the crucial detail. These ancient galaxies are not just moving through space. Space itself is expanding. It is a dynamic, stretching fabric. The longer light travels through this expanding fabric, the more the light waves get stretched and the redder they become. By the time the light from the early universe reaches James Webb, it has been stretched so far that it has dropped completely out of the visible spectrum and into the infrared. By measuring exactly how much that light has been stretched, we can calculate precisely how long it has been traveling. It is a flawless cosmic clock. And this is where the paradox locks its jaws around us. When we read the red shift of these massive, fully formed galaxies, the physics is undeniable. The red shift tells us this light has been traveling for over 12 billion years. It definitively places these galaxies in an era just 300 to 400 million years after the Big Bang. The cosmic clock guarantees that this environment is a mere infant in the grand scheme of time. But the physical characteristics of the light, the sheer brightness, the mass of 100 billion suns, the smooth galactic disks, and the heavy dust of dead stars all scream that these structures are billions of years old. We are looking at an irreconcilable contradiction. It is as if an archaeologist dug deep into the earth and found a perfectly preserved Roman coin in a layer of rock that is verifiably 2,000 years old. But when they take the coin to the lab and analyze its composition, they discover it is forged from modern aerospace-grade titanium. The location in time tells you it is ancient and primitive. The physical structure tells you it is mature and highly advanced. Both facts are mathematically proven by our instruments, yet they cannot both be true in the universe as we understand it. This is not a simple rounding error. This is a fundamental paradox that strikes at the very heart of reality. We are staring at a universe that is simultaneously a newborn and an elder. When you face a paradox this severe in physics, it means something in your foundational understanding of reality is broken. It means one of our core assumptions must be completely wrong. It forces me and every other physicist to consider two terrifying possibilities. Ament 1. Our understanding of how matter behaves is fundamentally flawed. Somehow, under extreme conditions we do not yet comprehend, a gas and dark matter can collapse and form massive black holes and hundreds of billions of stars at a speed that completely defies the known laws of thermodynamics. Option 2. The cosmic clock itself is wrong. If these galaxies truly required billions of years of slow evolution to form, then the universe simply cannot be 13 billion years old. The Big Bang might not have happened when we think it did, or perhaps the Big Bang was not the true beginning at all. We have backed ourselves into a corner, and the only way out is to break our current models of the universe. To solve this impossible puzzle, we have to push our minds past the comfortable limits of everyday logic. We have to question the most fundamental assumption we have about reality, the idea of an absolute beginning. For the past century, we have operated on a single powerful premise. The Big Bang was the starting line. Before it, there was no space, no matter, and most importantly, no time. We tell ourselves a simple logical story. First, there was absolutely nothing. Then there was something, and that something has been slowly growing and evolving ever since. But James Webb has forced us to confront a terrifying question. What if the starting line was actually a finish line? This is where reality truly begins to break your brain. In theoretical physics, we have mathematical models that suggest the universe does not just happen once. We call it cyclic cosmology, or the cosmic bounce. To understand this, I want you to imagine taking a deep breath. Your lungs expand, holding the air for a moment, and then you exhale, collapsing your lungs back down. Now, imagine the entire cosmos doing exactly that, but over trillions of years. In this scenario, a universe exists, expands, and grows old. Eventually, the expansion slows, stops, and gravity begins to pull everything back together. The universe contracts, galaxies collide, stars are crushed, and all the matter and energy in existence is violently squeezed back into an unimaginably dense hot state. We call this the Big Crunch. But instead of shrinking down to a point of absolute zero, a point of nothingness, the immense pressure hits a physical limit. It rebounds. It violently explodes outward in a colossal expansion. To anyone living after that explosion, it would look exactly like a Big Bang. But it is not birth. It is a cosmic exhalation. It is a bounce. If our universe is the result of a cosmic bounce, it provides a breathtaking solution to the impossible galaxies. James Webb is seeing, think about building a magnificent stone cathedral. If you start from scratch, you have to find a mountain, quarry the stone, cut the blocks, and slowly lay the foundation. It takes generations of hard, slow labor. This is what we thought the early universe was doing. But what if you arrived at the building site and found that the massive stone foundation was already laid? The walls would go up incredibly fast because the hardest part of the work was already done. In a bouncing universe, some of the most extreme objects from the previous reality, specifically unimaginably dense black holes, might actually survive the crushing transition of the bounce. They do not get destroyed. They pass through the unimaginable fire of the Big Bang and emerge into the new universe as cosmic fossils. So when the hot fog of our early universe began to cool, it did not have to wait for gravity to slowly, painstakingly pull microscopic particles of hydrogen together over billions of years. The gravitational foundations were already there. These surviving primordial black holes acted like colossal cosmic vacuum cleaners, instantly and violently dragging massive amounts of gas into their orbit. This means the giant galaxies we are seeing just a few 100 million years after the Big Bang did not actually grow that fast. They cheated. They had a head start. They were built around the invincible remnants of a universe that died before ours was even born. When I look at the James Webb images now, I do not just see the baby pictures of our cosmos. I see ghosts. I see the heavy ancient architecture of a previous reality casting its shadow over our own. The dust we are detecting, the mature stars we are observing. They are telling us that time is not a straight line drawn on a piece of paper. It might be a circle. And if time is a circle, if the universe breathes in and out, then the light James Webb has captured is not just older than we expected. It is older than time itself. At least the time we thought we knew. We are looking across the boundary of creation into the echoes of a world that existed before the Big Bang. But in science, we do not simply embrace the most fantastical idea because it is beautiful. The hard truth about astrophysics is that before you rewrite the laws of time and declare the Big Bang a mere cosmic bounce, you must first ask a much more humbling question. Are we being deceived? Light is a messenger, but it can also be a master illusionist. When I stared at the data from James Webb at those impossible massive galaxies that threatened to break our understanding of the universe, I knew we had to systematically attack our own assumptions. We assumed that the intense infrared brightness we were seeing was coming from starlight. We assumed that to produce that much light, a galaxy must contain hundreds of billions of mature stars. But there is another way to light up the dark, and it is far more violent deep within the centers of these ancient galaxies. James Webb detected the unmistakable erratic signature of supermassive black holes. Now, a black hole itself emits no light, but as its immense gravity violently rips apart clouds of gas and drags them inward, that material begins to swirl into a massive disk. We call this an accretion disk. As the gas spirals closer to the event horizon, it accelerates to a significant fraction of the speed of light. The sheer friction of this fast-moving gas rubbing together generates heat so extreme that it blasts out intense radiation. This process is so incredibly bright that a single feeding black hole can outshine the combined starlight of every single star in its host galaxy. It creates a brilliant cosmic mirage. When we went back and carefully stripped away the blinding glare of these black holes from the James Webb data, the impossible galaxies suddenly shrank. Without the optical illusion created by the black hole, the actual stellar mass of these early galaxies fell back into a range that perfectly fits the timeline of the Big Bang. The standard model of cosmology was safe. The universe is in fact 13.8 billion years old. But do not let out a sigh of relief just yet, because the hard truth is that we simply traded one impossible paradox for a much darker, much more terrifying mystery. By proving that the light came from supermassive black holes, we confirmed that these monsters existed a mere 300 million years after the beginning of time, and they are incomprehensibly huge. We are talking about black holes with the mass of 1 billion suns sitting right there in the cosmic dawn. To understand why this breaks physics all over again, you have to understand how a black hole grows. A black hole does not just instantly consume everything around it. There is a strict mathematical speed limit to how fast it can eat, known as the Eddington limit. Imagine you are trying to fill a small bucket with a high-pressure fire hose. The water hits the bucket with so much force that it blasts right back out. You actually fill the bucket slower by using maximum pressure than you would with a gentle stream. A black hole faces the exact same problem. As it pulls matter in, the friction generates that intense light and radiation I just mentioned. But light has physical momentum. It exerts pressure. If a black hole tries to eat too fast, the intense radiation it creates physically pushes the surrounding gas away, starving the black hole and stopping its growth. Because of this universal speed limit, it should take billions of years of slow, steady feeding for a black hole to reach 1 billion solar masses. Yet, James Webb has found them sitting in a universe that is only a fraction of that age. It is physically impossible for them to have grown from the collapsed cores of early stars. There simply has not been enough time in the entire history of the universe for them to eat that much matter. So how do you get 1 billion solar mass black hole in an infant universe? They did not grow. They must have been born massive. And that means something in the dark, very silent fog of the early universe caused colossal clouds of pristine gas to collapse directly into black holes, bypassing the star phase entirely. It is a process that requires a delicate, almost impossible balance of forces, a mechanism we have never observed and barely understand. The hard truth is the universe is hiding a dark mechanisms of creation that we are only just beginning to uncover. If these supermassive black holes did not grow through billions of years of slow feeding, then we are left with a staggering conclusion. They had to be born massive. But how do you skip the star phase and jump straight into a cosmic behemoth? To understand this, I want you to imagine trying to build a towering skyscraper. The standard way, the way we thought the universe built things, is to slowly lay down one brick at a time, floor by floor. It takes years. In astrophysics, those bricks are individual stars. Over eons, they cluster together. Some die, some merge, and eventually their remnants form a larger black hole at the center. But the data from James Webb is forcing us to imagine a completely different construction site. Imagine walking up to an empty plot of land and instead of laying bricks, the entire ground suddenly caves in under an immense localized weight, instantly forming a perfectly compacted massive foundation in a matter of seconds. We call this direct collapse. In the dense, very dark fog of the infant universe, there were colossal clouds of pristine hydrogen gas, millions of times more massive than our sun. Normally, as a cloud like that cools, it shatters and fragments into millions of smaller pieces, which then ignite to become normal stars. But what if something stopped that fragmentation? What if an intense bath of radiation from a nearby source kept the gas hot just long enough? Under those precise extreme conditions, the cloud does not break apart. Instead, its own monstrous gravity takes over. The entire unbroken cloud collapses inward in one single catastrophic freefall. It compresses so rapidly and violently that it completely bypasses the star phase. It crushes itself directly into a black hole with the mass of 100,000 or even 1,000,000 suns, all in a cosmic blink of an eye. This flips our entire understanding of reality upside down. For a century, we believed that galaxies formed first and that supermassive black holes slowly grew at their centers like a pit growing inside a peach. But James Webb is telling us that the pit came first. The supermassive black holes were the dark, heavy seeds of the early cosmos, and the galaxies, the stars, the planets, and eventually us grew around them. We are standing at the absolute edge of human knowledge. The rules of gravity and time that we have relied on are breaking down, revealing a universe that is far more violent, complex, and deeply mysterious than we ever dared to imagine. Before we reach our final conclusion, I want to take a brief moment to speak directly to you. Navigating these profound, mind-bending concepts is not easy. It takes a relentless, unyielding curiosity to look into the abyss of time and question the very nature of existence. If you value this kind of deep, uncompromising scientific exploration, and if you want to support our mission to bring these mysteries to light, I invite you to use the Super Thanks feature below. Your direct support is what allows our team to keep analyzing the data, keep challenging the established models, and keep pushing the boundaries of what we can understand together. To everyone who has already supported the channel, I am deeply grateful. You are fueling the future of discovery because the journey is far from over. When I look at those infrared images from James Webb, I realize we are not just looking at a broken timeline. We are looking at a profound opportunity. Every time the universe defies our logic, it is inviting us to evolve. It is telling us that the story of creation is not a simple, neat textbook chapter that we can memorize. It is a wild, untamed frontier. The impossible galaxies and the giant black holes of the cosmic dawn are not mistakes in the data. They are the blazing signposts pointing toward a new revolution in physics. They demand that we let go of our comfortable illusions and embrace a cosmos that is infinitely stranger than we thought. The foundation of modern cosmology has cracked.